Hello team, I put together a quick video to go over a couple manifold pump strategy options with three common examples that you'll see in the market quite a bit. So to start with a little bit of a recap of primary secondary piping, our goal here is to keep this pump here, which we would call our boiler pump in this application if this is our boiler, and this pump, which is our system pump, from fighting each other. So the idea is this is a split between this wheel and this wheel over here. I like to think of it as a bicycle on a rack on the back of a car or something like that. You can spin the front wheel without it affecting the back wheel here, so those two can spin independently. If you don't have primary secondary piping, or in this case I put in a hydro separator, what happens is this wheel ends up pushing that wheel, or the other way around if one of them is bigger, or depending on how many zones are opening and closing. So primary, secondary, closely spaced tees, whatever you want to call it, is just to keep these two areas separate, basically. So I also like to talk about traffic when I try and explain different zoning applications. So let's pretend, instead of the hydronic system we showed on the slide before, that this is a road, and instead of gallons per minute, we're going to talk about cars per minute here. We have a highway full of cars right now. We'll say these are the different exits. All the exits are open. We've got plenty of places for the cars to go. As we start to close these exits, now we have more cars trying to go down a fewer number of roads. So we're starting to back up the traffic. In the zoning case, that is like closing a zone valve. And the issue is that, let's say we close one more road here. Now we have all of these cars trying to go down one road. And what that can cause, if that is water in a hydronic system, is actually an increase in velocity noise. And you can start to basically deadhead your pump, because unlike cars, the water is not being modulated at all if you have a single speed pump. So you're always sending this amount of cars or gallons per minute down the one road, and that can be stressful on a hydronic system. So we have a couple ways around that. We are using a Rahau manifold here, so we're going to be able to balance independently per zone, but we have to figure out how to properly pump that. So we have three different options here. The first one is an ECM pump, so that's an electronically commutated motor, as opposed to a permanent split capacitor motor. So a permanent split capacitor is just going to be a standard 1-speed or a 3-speed pump that's basically on-off, but it doesn't modulate at all. Where an ECM pump actually slows down and speeds up based on the change in pressure upstream and downstream of the motor of the pump. So it is a modulating delta P, delta T sometimes pump. So what I like to think of with that is it's almost like you're traffic metering, because you're going to slow down this pump if you only have one lane open. So just based on the pressure difference between this side of the pump and this side of the pump, it's going to speed up or slow down and have the appropriate amount of traffic on the lanes that are open. So the nice advantage there from an energy standpoint is when you're down to the lowest amount of lanes open, you may only be using 4 watts, and at full speed you may be up to 40 watts. So it's a lot less energy than the other options I'm going to show you. And since you're not having too many cars go down that open lane, you avoid deadheading the pump, and you avoid the noise velocity issues when you only have one of your zones open, or a couple of 10 zones open, something like that. A way to fix that with a differential bypass valve and a permanent split capacitor pump. So let's say this is a 3-speed pump. What we have now is zones are starting to close, but we take that extra traffic and we take it through the differential bypass valve here. So that's what the Rahau version looks like that goes on the end of the ProBalance manifold. And instead of sending all of the traffic down the one open zone, we let those other 2 lanes of traffic basically just go around and come back into the return and go this way. So we have a spring-loaded off-ramp that's available only when these other zones start to close. So it's a good option. I wouldn't say this is the best option, because we're still on a high speed using 87 watts of our pump here, and it's not an exact science. So when you set these differential bypass valves, you'll get it right for probably one of those applications, but you may be bleeding a little bit of additional traffic through, in some cases, when you don't need to. So it's not perfect, but it is better, and it's going to keep your pump from deadheading. The third option, which is an okay option, is zone pumping. This is pretty straightforward, that you just have 3 separate roads, 3 separate pumps. So in this case, even if you had those pumps on low speed, if it's a 3-speed pump, you are going to be using a lot more energy than you would to do the exact same thing with an ECM pump or even with the differential bypass valve. So that's not as common anymore, but it is still an option. And those are the 3 basic examples of how you could zone a hydronic system.